All right, hey guys, welcome back to the channel. Thank you for those who have been supporting. Really need help, so please like, share, tell a friend to subscribe. What we're going to be looking at today is the three-factor derivative for the exponent and the logarithmic functions, right? So if we have exponential functions and logarithmic functions, we would want to know how to find the derivative of those. Now, there's only three-factor. I think they call it the three-factor derivative or something like that, and it does work. All right, I've looked at it, and it was actually after leaving college. I found out this method because it wasn't taught to me like this. So here's go. So an exponential function is in the form b to the f at x, right? Where the variable is in the exponent. Okay. Now, if we're going to take the derivative of a function in this form, we just need to know three things. We're multiplying three factors, that is, right? But we need to know what those three factors are. So d by, let's put that in green. Let's say d by dx if b f at x is equal to, so this is how we do it. We're going to take the derivative, right, of the exponent. So that's f at x. So the derivative would be f prime of x, right? So we're going to write it like this, f prime at x, right? And we're multiplying that by the natural log, that's ln, of the base, which is b, and we're multiplying that by the original function, that's b to the f at x. So that's b to the f at x. And once you know this, any function written exponentially looking like this, you can use this to find its derivative, right? For example, the famous one that we all know, e to the x. We know that the derivative of e to the x is e to the x. So e to the x is an exponential function. So we're going to use this right here to find the derivative of e to the x. So we're taking d by dx of e to the x. So we need to take the derivative of the exponent. The exponent here is just x. The derivative of x is 1. So we have 1. We're multiplying that by the natural log of the base. We just have the base here is e. So that's ln e. And we're multiplying that by the original exponential function, which is e to the x. There we go. And now we can simplify. 1 times ln e is 1, so because this is just like log of base e of e. So if you could recall this fact, the log of base a at a is just equal to 1, right? Because we could rewrite this exponentially, or as an exponent, that's just a to the 1 equal to a, right? Which makes sense. So ln e is 1. And we're multiplying that by e to the x. So 1 times e to the x is just e to the x. Oh, that's not an e. So we get e to the x. And that's why dy by dx, or not dy, d by dx of e to the x is just e to the x. All right? Now we're going to be looking at the logarithmic functions. All right? So let's erase this right here. And if you want another look at that, you could just go back and watch that again. All right, so a logarithmic function right here is as log of base, let's put b for the base again, of f at x, right? So f at x here is the argument. You got the base, we're taking the log, right, of that base. Now, if we need to get to the derivative of this function like this, again, it's going to be three factors with a little bit of tweak. So we take d by dx of log, let's put this right here, of log of base b of f at x Now, we're still going to take the derivative of f at x, which is just the argument right here. So it's the derivative of f, so that's f prime at x. So f prime x, that's just the argument, the derivative of the argument. We're multiplying that by 1 over the natural log of the base. This is the base of b, right? So whatever b is, natural log of the base. And we're multiplying that by 1 over the argument. All right? So once you remember this, right? And it's not hard to remember, right? It's not, I don't think it's something that you have to deeply memorize, because once you look at it, it immediately become like, you know, intuitive, I think. The derivative times 1 over the natural log of the base times 1 over the original argument. Or you could say the derivative of the argument times 1 over the natural log of the base times 1 over the argument, whichever way works. So let's do the derivative of ln x, because everybody knows that the derivative of ln x is 1 over x. Now, how do we get there? Now, I'm going to rewrite ln x as in this form, the log, because this natural log is just log of base e, right? Because I want you to see what's happening, right? So this is the same as, this is equal to d by dx of log base e of x, right? Because the natural log is just telling you that it's log of base e to the x. So this three-factor derivative now we're going to use. So we're gonna focus here. We're going to take the derivative of the argument. The argument here is x, right? So the derivative of x is just 1. I'm going to write that in purple. Times 1 over the natural log of the base. What's the base here? E, right? So the base here is e, so that's 1 over ln e. And we're multiplying that by 1 over the argument, which is just x. And as you can see here, again, we got that 1 over ln e. Well, not 1 over ln. Before we had just ln e. Now we have 1 over ln e. But ln e is 1. So 1 over 1 is just 1 just the same. So that's 1 times 1 times 1 over x, which is just equal. Let's make that look more like an x. X right here. And then that's just equal to 1 over x. And that is why the derivative of ln x is 1 over x. And this works for any logarithmic function. All right. So both of these have been very, very useful. Right. Once you remember what the three factors are, you're good to go. All right. Thank you for watching. See you in the next video.